So finally we start with the monohybrid cross. Monohybrid cross. Mono means one. Okay, so we will be studying one single trait of a plant. One single trait. Alright, so we'll be studying that. Now let's start. So to study that, what are we going to take is that in terms of P1, that is the parental generation, we are taking one tall plant. This is not two tall plants, by the way, one tall plant. I have told several times about the genotype, phenotype. Please re-watch those videos and then come and listen to this one. So we are taking one tall plant, and crossing it with one dwarf plant. Fine. Done. Now we have to form the gametes. Watch the last video on gametes. So what can be the gametes? It will be capital T, small t here and small t there. Alright, I think I'll go to the next slide, so that will be better. So let's do it once again. For P1 generation, parental generation, we are taking capital T, that is one tall plant, and small t, that is one dwarf plant. So let us assume that this capital T is a father parent and the small t is the mother plant. Okay, now we form the gametes. This is T, this is T, small t and small t. These are the gametes. Now we have to find, oh my god, where has this gone? Okay, now we have to find out that what are the possible children, or we can say what are the possible progenies that can be formed with the help of these gametes. Right, now we draw the Punnett square. In this way we draw it. Okay, let's see. This is the father's side, and on this side we'll write the mother side, the female. So on the father side we have capital T, another capital T, male gametes, and the female gametes are small t and another small t. Done. Now this is very simple. T, capital T, small t is equal to this one, then T's are this one, then again this is just like multiplication, then this one and this one, now again this one and this one, you have to just multiply. Okay, so this is the Punnett square. Now we have made the Punnett square and found out that we find 4 children here. Now when we see these 4 children, we have the genetic code with us, we cannot see the plant, so by the genetic code we can understand that actually is the plant a tall plant or a short plant. And by seeing this genetic code we can find out that all the children or all the progeny or all the offsprings in the F1 generation, that is the filial generation, we say, are tall plants, heterozygous tall plants. Okay, heterozygotes, not homozygous. See, the father parent is a homozygous tall, capital T and capital T. The children are heterozygous, capital T and small t. Right. So what happened is that, so we find that all progeny are heterozygous tall. Now Mendel, he was a bit surprised to see that okay, the father is pure tall, but the children that we have found are heterozygous. Okay, so like are they same to certain extent? He was very surprised to see that and very curious to know what can be the possible offsprings if we take 2 2, let me change the ink now. Now let me take black. Okay, and he wanted to see that suppose if I now take one progeny and the other progeny, okay, and cross it. So now let's see parental generation 2. So now he has taken one parent, and this is, I mean, he has taken two progenies, two children from here, and have crossed it. Okay, and both are this time heterozygous. In the first parental generation, what did we find? One was homozygous tall, one was homozygous dwarf. Here what we see is that both are heterozygous tall plant. All right, next what will be the step? Gamete formation. What will be the gamete? Capital T, small t, capital T, small t. Fine, done. Form the Punnett square. Now this will be filial generation 2. Form the Punnett square. On this side we write the male gametes, here we write the female gametes. What can we write in the male? Capital T, small t, right? And in the female side also we can write capital T and small t. Now simple multiplication, this t and this t, t, t. This t and this small t will be this one. Then this one and this one is this, okay, and then small t is small t. Now after crossing the F2 generation, he found that there are, if we have to write the phenotypic ratio, we need to write it in this way, phenotypic ratio. That means what? By observing, just by looking at the genetic code, we can understand that there are three tall plants, and one is a dwarf one. Okay, 3 tall and one is dwarf. Fine. But when we find out the genotypic ratio, whatever you want to say to be as genotypic ratio, now we will say it in very detailed format. What we find is that we find one pure tall. See, this is the pure tall, capital T is pure tall. 2 heterozygous tall, this is one heterozygous, this is one heterozygous, and one pure dwarf. Okay, dwarf. This is pure tall, heterozygous tall. I am writing it in short, okay, and this is pure dwarf, right? So this is the result of the monohybrid cross, that in phenotypic ratio we found out that, see, in the monohybrid when cross, Mendel found out that in the first F1 generation, he did not find any recessive character being expressed. Okay, he found that the parent tall was a homozygous one, but the children are also tall, but they are heterozygous. So what did he do then? He took 2 of the progeny, those are heterozygous, and again crossed them. While crossing them, then he found out in the F2 generation, that is the filial generation, the progenies that were formed, he found that if we look, just observe the phenotype, then we can understand that there are 3 tall plants. This is one tall plant, this is one tall plant, this is one tall plant, and one recessive character has got expressed. Okay, so the ratio is 3:1. But now if we go in detail, that okay, fine, via the genetic code we can understand which one is pure tall, which one is pure dwarf, which one is heterozygous. At that point of time, he found that okay, we have one pure tall plant, there are 2 heterozygous tall plants, and we have one homozygous dwarf. That is, one recessive character has got expressed in the F2, that is filial generation. So this is what is all about monohybrid cross. See, it is nothing so difficult until and unless you are clear with this. You have to find out the gametes, then you can easily put it on this side it's the male and on this side it's the female gametes. and then just keep on multiplying. This is just simple thing. All right, so in the next video we will start with the dihybrid cross. Please rewatch this video once again. Okay, thank you, bye.